3, 2, 1, 0.
not doing? Oh, there we go. All right. Thank you for letting me know. I've been talking for a while, apparently to no one. That's cool. I'm glad to know that my mic was muted. Let me adjust this camera a bit. I should... I usually do a sound check before, but I forgot to this time. Thank you. So, I don't think anyone was actually watching before. I'm not sure it matters, but maybe I will repeat some of what I was saying. Hope the sound is working. I'm using this, I use this, it's called H5 handy recorder from a company called Zoom. It's a pretty nice little product, and then I'm using this Rode Link. It's like a wireless lav mic. Anyway, it works pretty well most of the time, but apparently, even though it was all hooked up and the like levels were moving, it was not actually coming through on OBS. But I just fixed that, so I think we're good now. Anyway, I'll repeat quickly what I was talking about. I was just sharing what I was working on last weekend, which was another project of mine called Conky. Maybe you could have inferred what I was saying. But anyway, I was just talking about how I spent basically the whole weekend building out this elaborate CI pipeline with GitLab. And in doing that, I discovered that GitLab has a limitation which exists on like a number of things that integrate with GitHub. But anyway, it has this limitation where it doesn't automatically build external PRs, which is kind of annoying, especially for something open source like Conky, where I get a lot of external PRs, and I really just want the build system just so that I can have automated checks around those external PRs. Makes everyone's life a lot easier, helps keep the code quality up, and so on. I also wanted to be able to do FreeBSD builds, and GitLab supports FreeBSD with their runners. So anyway, that's what I was working on last weekend. That's why I wasn't streaming or anything. But yeah, I was talking earlier with my muted mic about new Rust announcement, which is pretty exciting. Rust 1.33. There's no like blockbuster features in this, I think, but it's cool that the project is moving so fast, and it's gone from like 1.0 and I don't know when did 1.0 come out? Like what, like 2 years ago or something? 1.0, it was a while ago, okay. It felt like wasn't that long ago. May 15, 2015. Anyway, the language is moving way faster than something like, for example, C++, which is, you know, something I have a sort of love-hate relationship with. I really hope that Rust can replace something like C++ in the future. The only thing I would say that is holding something like Rust back from really being a full replacement for a C++ or something is just the fact that the C++ ecosystem is more mature, and you know, there are a lot of C++ libraries and so on. But the whole Rust space is moving so quickly that's exciting. Anyway, oh, and I was also was searching and just talking about how I didn't realize that. So I did a search. I was just trying to see if my project actually shows up when you do a Google search, which it does not. And the first two results, I think, are from some people who apparently tried to do what I'm doing, but they didn't get that far along. Neither of them got past chapter 2. This person, Mitten, stopped at chapter 1, and Ranveer stopped at chapter 2. So 2 years ago. So if I can get past chapter 2, then I'll be excited. Yeah, the Rust community is pretty small, but it's incredible. Like, I started working on another project, which is a geez, I wasn't sharing my screen. I started working on another project, which is a make sure that's the right which is a GitHub bot, GitHub/GitLab bot for building external, building changes from external PRs on GitLab. And I got my inspiration actually from this bot from the Cock project. This bot actually does what I want it to do, but it does a lot more than I wanted it to do. And there's like a few specific things that I want to do, so I decided to just start writing my own bot. And so I've been doing that, and haven't finished it. When I finish it, I'll make the repo public and everything. I just don't want to do that while I'm like pushing a million commits that are just a bunch of garbage at this point. So anyway, so Cock uses this, and I found out about this because there was a GitLab discussion somewhere. Where was it? I have to go into my email. Your mission, should you choose to accept it. Sorry, I don't want to dox that guy, but he sent me an email and I just opened my email, so that's your problem. Anyway, there's this thread on GitLab. If you're interested in like CI stuff, where there's a bit of discussion about this problem, you can just search for it. You'll probably find it. But basically, you can't build external PRs on from GitHub repos that are mirrored on GitLab. For CI, you can't build external PRs, which is a bummer. And there's a reason for that. It has to do with some concerns about secrets, and theoretically someone could steal your secret simply by opening a PR that just echoes the secrets, right? And then just like they appear in the log, right? However, in my case, I don't care. There's in my case, for like the conky thing, I only have one secret in the repo, and all it is a key. Where is it? A key for the sccache bucket. I have a bucket on GCS, and that's it. So like worst case, someone takes that key and they like write a file to the bucket. So what? I probably would not care. What's that random cat generator? Random cat generator. I'm not sure what you're referring to. But anyway, I mean, like this is public on GitHub if you want to look at it. So, are you talking about this maybe? Oh, the new tab page. Yeah, this. Oh, it's called the Chrome extension. This is called a Tabby Cat extension. This is some Chrome extension that was made by a friend of a friend, and I've had it as my Chrome extension for a while, my new tab page for a while. Yeah. Anyway, all right. Let's talk about Rust. So let's talk about Kraken code interview. Last time, I think. Close this. I think where we left off was we're doing linked list stuff, and I remember after I wrote this, I had a realization that there was like a pretty decent optimization I could do to this last problem I did here, but I'm not gonna bother going back and fixing it. I thought about just like patching it, but I didn't want to do it unless I was doing it as part of the, you know, the video series here. I'm trying to remember what this did. I've completely forgot. Oh yeah, delete middle node. I remember. So, oh yeah, it's these lines of code right here. The way this is implemented, I make 2 passes over the list because that's like the this is basically the easiest, most naive way to solve this problem. However, it would be trivial to rewrite this to make only 1 pass over the node or over the list, and I could do that by simply keeping track of the last, like the previous node visited. In fact, why don't I just do this? This will be a good warm up to get back into this. All right, I hope that's readable, big enough. I think so. It's very readable for me, but I'm standing here, so not really sure what it's like for those who are not standing here, but okay. So yeah, let's fix this algorithm. So test remove node. Where does it? Oh, maybe it wasn't this one. It was one before it. Am I looking at the right problem? Append. Oh yeah. Sorry, I was looking at the wrong problem. It's this. No, is it this problem? Oh yeah, it is this problem. Kth to last, because because I do 2 passes over the list, right? Here's pass 1, and then here is the second pass. Each one of these iterators is basically like effectively looping over the whole list. So to get the kth to last node in the list, to do it with 1 pass, I would just need to iterate, and then when C is at least K, then I start keeping track of the node, the like kth, the last one. So yeah, the algorithm really doesn't look that much different except for this part right here. So yeah, so what would be different is I would do this. So stop at, so the reason I implemented it this way is because I don't know the length. You don't know the length of the list. There's no, certainly you could like create an implementation that keeps track of the length of the list. Like every time you append an item, you can, store some metadata somewhere, right? But in this case, you don't really know the length of the list. So what I want to do to change this is just say basically do the same thing, but I want to keep track of the previous node. So I'm going to say like let kth to last node equal none, and then this is going to be one of these guys, right? Optional node ref. Get rid of this. Okay. So I need to essentially count into the I need to count into my list, and I need to keep track of the like kth previous node, if that makes sense. I don't know if I'm making any sense, but all right. So for node in how do I express this? It's really tricky, by the way, to like write code and simultaneously explain or like talk about what you're writing and what you're thinking, which I suppose is part of what makes coding interviews challenging in general. The fact that in the interview there's usually an expectation that you can actually explain your thinking in a reasonable way, such that the interviewer can understand you, at least. But I don't know, it depends. I think like if you listen to like any of the material like from Google or whatever about what we look for in interviews, they'll usually say things like, well, we don't necessarily expect you to get the right answer, except they do. I think that's a lie. Generally, if you fail the problem, like unless you blew their minds in some other way, you're probably not going to pass the interview. But anyway, what they'll tell you is that what they're looking for is how you approach the problem and how you explain your approach and so on and so forth. But that's only part of it, right? Like really there are two things you need to do to pass the interview. One is that you should be able to explain what the F is that you're doing, and like the second thing is that you should be able to actually do the problem, or at least get close enough to a solution. It may not be, like if you're doing it on the whiteboard or something, then it might not be perfectly syntactically correct or whatever if you can't actually test it. But you should be able to get pretty close to a solution. All right, anyway, for node in self.iter, where are we? Okay, so basically we're counting in, every time I iterate, I'm going to count how many nodes into this I am, right? And so if C is greater than K, then so this should be different. So basically I should say if C is equal to K, there are two conditions here, right? So one condition is that we're basically we're at the head kth node or whatever, right? And in that case, what we want is we actually want the head. So here we're going to say, yeah, self head. We're going to say the kth to last node is equal to the head. Yeah, this should be mutable, by the way. And I think we're good there. Sweet. Okay. And then if otherwise, right, then we would want the next node, right? So that's going to be the kth last node will become the kth last node, blah, 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 borrow next as ref cloned, right? What did I do wrong here? I guess I need to unwrap this because it's an option. And I'm just ignoring the result of this unwrap here because I've already basically been through the list. So I'm reasonably confident that I don't need to actually look at the node here. I'm reasonably confident that it is right. Okay, and then here I just return kth last node, basically. I believe that is it. Let's run that. I hope what I said made sense. It looks like it's failing, and I think it's because I'm I've gotten off by one error. So C, so if I say, let me just think through this here. So, so if I want the 1th to last, basically the node before the last, then yeah, when C equals K, which would be 1, C will be 1, then I should be taking the head. But that's not quite right. So I think this needs to be, I need to count, I need to increment my count after, like this. There we go. That's right. Okay, so yeah, that's it. So that is the thing I thought of that I wanted to implement after I did this, and now this is slightly more optimized. So it's problem 2. Let's go on to problem 4. Let's see. Paste problem 4. Let's open up the book. Let's see what it says. Let's go to the book. Go into the book. We're going to the book. All right. Got the book here. We're going to problem 4. Problem 4 looks like an interesting one. Please focus. Please focus the book. Focus on the book. There we go. Problem 4 says partition. You can kind of guess maybe where they're going with this one. Write code to partition a linked list around a value x such that all nodes less than x come before all nodes greater than or equal to x. If x is contained within the list, the values of x only need to be after the elements less than x. See below. The partition element x can appear anywhere in the right partition if it does not need to. It does not need to appear between the left and right partitions. All right. I think I understand that. Okay. There's an example there. Let's start by just turning the example into a test here. We are adding test partition. Let's change the type of our list. Use an integer. Okay, so the example here had had what? 3, 5, 8, 5. 3, 5, 8, 5. Three, 5, 8, 5. 10, 2, 1. Okay, 3, 5, 8, 5. 10, 2, 1. All right. And we want to make a new list and say let list partitioned equal list1.partition, and in the test case they provide the partition on 5. And then the result should be, let's make an iterator here. It should be let iter equal list partitioned dot iter. And then we should have assert. We should have 351. What are we calling on the iterator? Next. Iter dot should be mutable, I believe, as well. Iter dot. How does iterator work? Just want to look and see. Okay, so gives you the head, and then next is an option to the next item. All right. Iter next. And the item. So presumably I dereference this guy to get the item. I'm not sure. Hold on, let me just try it. Iter. So assert iter equals 3. Let me just test this. Comment that out. Gotta go test. Why does it not like that? Not found in the scope. Oh. Dirt. Change this to list 1. No, I can't deref that. Type iter at 32 cannot be dereferenced. Rust iter. How does this work? Iterator type item. Oh, I see. So never mind. I'm misunderstanding how. I forgot that Rust iterators are stateful. So the way that this works is that, yeah, you call next on it, and each time you do that, it actually returns a value. Right? Cannot apply. What am I doing wrong here? Am I using this macro wrong? No. Assert. It's just assert. Boom, right? Oh, assert equals. My bad. There we go. Node. Oh, yeah. What do I call this? Data? Like that? What's a node? Node. Data. Yeah. Node. I'm going to need to borrow that. Node. Unwrap, borrow, data. Right? Yeah, there we go. Okay, that passes. So that's doing what I want. So to make this actually work, I'm going to have something like this. Cargo format. Something like this. let me just fill out the test case. So the values expected are 3, 1, 2, 10. 3, 1, 2, 10. 3, 1, 2, 10, 5, 5, 8. 5, 5, 8. And that is it. So let us add partition. Partition. Now, partition is going to return a copy of a linked list. Yeah, I believe. And let me just look at something. So, in the example here, they have, oh dear, forgot to change my screen again. Man, I'm the worst at this. Really bad at it. In the example here, they have partition such that all nodes less than x come before all nodes greater than or equal to x. Okay. Got it. If x is contained within the list, the values of x only need to be after the elements less than x. So I'm looking at the code and I'm trying to understand exactly how this was implemented just by looking at the order. So in the example here, in the like the test that they have in the book, the order that comes out is 3, 1, 2, 10, blah, blah, blah. So if you imagine, like, excuse me, going over this list, so you'd come to 3 first, and you're comparing that to 5, and you would say, oh, okay, 3 is less than 5, so let me put that into the list. Okay, then you hit 5, and you would say, oh, okay, 5 comes after 3, so that cannot, I think the way that would work is that would not go in, you would set that aside, essentially. Yeah, and okay, so then you get to 8, again, yeah, you set that aside. So it looks like, yeah, I think I understand how it would have been implemented in the book. Let me just run with it here. All right. So partition. Let's start that guy. Impl linked list. We're gonna add a partition function. Let's just put it right here. Partition and partition value t. And this will return a new linked list of type t. All right. Is that going to compile? Is the compiler happy? No, of course it's not. Of course it's not happy. Why would it be happy? This function's body doesn't return. Oh, well, yeah, okay. So linked list new. Let's just put that there. Method partition not found for this. Why is that? I don't understand that. Following associated functions to be used as methods must have a self parameter. Oh yeah, they're okay. Self There we go. Okay, we're good. Test fail, that means we're good. So this is pretty straightforward, right? All you have to do is do for node in self.iter, okay, right? And then say if node.borrow data is less than, right? Less than, yep. Partition value, add it to our new list, right? Let mutable new list equal that guy. New list dot append node dot borrow dot data. I want to make a copy of this data, but this is going to not necessarily copy. Can I just do this? Let's see. See what happens. Is that compiling? Nope. Oh, I need to return my new list at the end. Are we good now? Are we good? I don't think we're good yet. T might need a bound for, all right. Got it. T needs to be able to implement comparison, makes sense. Boom! All right. Let me restart my RLS again, because it likes to crash a lot on me. There we go. That's it. Okay, no, that's not it. So there's one more thing. So I also want a vector here. Mute new list. I'll just call this temp list, whatever. And then here I just want a vector. I just do an empty vector like that. Can I do that? I want it of type T. Is that good? Yeah. Okay. Then here I will just say temp list push T. Push this. Copy that. Okay, and then here I say for value in temp list new list push, sorry, append value dot I can actually just I wonder if there's a way to consume all of these items from my all these, they added a bunch of, okay, it doesn't work. I want to consume all the values from the vector. Is that a thing? Does that make sense? Swap, remove. I want like a take. Is there a take? Takes, linear, consume, drain. Creates a draining iterator. There we go. That's what I want. Range. Drain. Full range clears the vector. That's what I want. Drain. Drain. New list. Append. Value. Boom. Boom! Okay, it doesn't work. Left. 2. Right. 1. Where do we panic here? 144. So why is the order coming out different? And I think it's correct. It's just my ordering is different. But I would like to figure out why the ordering is different. It looks like so why does 3 appear first? I wonder. 3, because 2 comes before 1. Right. So the ordering of these makes sense. 5 and 5. I think. Yeah. 10. No, actually the ordering of these don't make sense. And if I just change the order of these to basically preserve the ordering, then I think it'll pass, right? Yeah, 5 comes before 10, like that. No, wait. 3, 2, 1. Okay, and then 5. Oh, it would be 5, 8, 5, 10. 10 should be last. Yeah, there we go. So that ordering is different, but the actual data is the same. Trying to understand whether or not I should care about the order. Let me take a moment here to try to understand the ordering. So how would you end up with that ordering? It's a little bizarre. I guess like one way that you could end up with that is that if you, well, it's like they're prepending rather than appending to the sublists. Well, whatever. I'm not going to worry about it because I think this is technically correct, what I have done. Although, since I'm not technically getting the exact same result, then maybe this would be considered a failure. Right? The partition element n can appear anywhere in the right partition. It does not need to appear between the left and right. Yeah, and there's nothing in that problem statement that specifies that the order matters. So I'm just going to assume it doesn't. Now we're done. We're done with problem 4. Get status. Add problem 4. Let me commit this change first. Whoops. Git add that guy first. Improve C2 P02 algorithm. Okay. Blah. Super annoying when it forgets my password. Even though I have the remember my password forever setting enabled, still somehow does not do that. Okay, git commit. Oh, I did commit -a. Derp. I want to do 2 separate commits. So let me just reset. Oh no, that file was untracked. Never mind, it doesn't matter. Didn't do anything. Let me copy the message that I just wrote. You're definitely not saving in my keychain. Thank you. All right. What's going on in my system? What the preferences here? Let me just store in 99999999999. Yeah. All right. Let's hope that sticks. Git add this guy. Commit. Problem 4. Quote. Oh man. What did I do? What have I done? Alright, let's push that up to GitHub. Pull first and push. I think I updated the README or something from the GitHub UI. So, alright, that is that. That is done. Build should be running on Travis right now, and it is. Alright, woohoo. Let's go on to the next problem. Yeah, does that sound exciting? Are you excited? Excited as I am about the next problem? So excited. So excited. So excited. All right. Next one is called sum lists. Sum lists good, sum lists bad. Sum lists. Problem 5, sum lists. Okay, focus. Focus please, technology. The future is now, but not now. It's like soon now. Future soon, but not right now. There we go. Sum lists, you have 2 numbers represented by a linked list where each node contains a single digit. The digits are stored in reverse order such that the 1's digit is at the head of the list. Write a function that adds the 2 numbers and returns the sum as a linked list. All right. I was just laughing to myself in my brain there for a moment about the fact that like the first 5 or 10 minutes of my stream was me talking with no sound. Oh my. Okay, let me read that again. You have 2 numbers represented by a linked list where each node contains a single digit. The digits are stored in reverse order such that the 1's digit is at the end of the list. Okay? Write a function that adds the 2 numbers and returns the sum as a linked list. All right, I think I understand this. Basically, like in binary, when you have a binary number, you can think of it as a field of bits where each bit has a position. And if you want to say, if you take like a binary number where you just have a string of 1s and 0s, like 1 0 1 0 1 0, and you want to calculate, you want to know like what is that number in decimal. The way that you do that is you would multiply the number, like the 1 or the 0, times 2 to the n, where n is the position of the digit, right? So it's the exact same thing, literally, that we're doing now, except instead of binary, we're doing decimal. And the digits are in a linked list, which is really weird, but hey, that's the problem. So let's do it. I think this is pretty easy. Shouldn't take long. Let's get into it. Copy problem 4, copy, paste, paste. Problem 5, sweet. Okay, delete that. See if my build passed. No, my build failed. I'm guessing it's because of some linter stuff. Variable C, oh yeah, okay. Yeah, I'm aware of that. I'm aware of that problem. I'm gonna fix that later. I'm getting clippied right now. I'll come back and deal with that stuff in the build later. Okay, so let me copy the example. Oh, hello, the Nutella Oreo. Man, that sounds really good right now. A Nutella Oreo? Are you European by any chance? I'm doing well, by the way. Thank you for asking. Nutella is a big deal in Europe. In fact, I don't know why it's not more of a thing in America. Oreos are really good too, and definitely an Oreo dipped in Nutella is pretty good. But anyway, okay, so the examples here, 716, okay, 716, 592. 716, British, Sweden, Turkish parents. Wow, very international. I guess I'm technically British too, but I don't really identify as British. I've never lived there, really, or spent much time there, but my one of my parents was born there, so. I grew up in Canada for the most part. I live in New York City now, however. That's that. So, okay, left, new, left, append. What are the values here? We have 716, 716. All right, and then let's make a right. Right equals linked list. I32 new. Right append. Right append 592. 592 92. All right, and what do we call this again? We're calling this sum lists, and the output should be 219. Now, since this problem is sort of stupid and specialized, like this is specific to integer types, I'm not going to implement it for linked lists of any type. I'm only going to implement it for linked lists that are integers, integer types. I don't know if there's a way to express that in Rust, actually. Then again, you know, I'm like a Rust noob, but like if I want to say implement for any type that is a type of integer, I don't know how to do that. All right. Okay, so self, this is going to take in a self, and then this is going to take in another linked list of type I32, other list, that can be a reference, and it's going to return a new list, right? Yeah, new list. All right. Let mute new list equal linked list of type i32 new. Something like that. All right. Does that build? Nope. Remove. What did I do? I copied and pasted the wrong thing. Add backward. So there's two parts to this problem. One is that you're supposed to do it with the digits going forward, and the other is supposed or backward, and the others that you're supposed to do it forward. So I'll do backward first. These problems are so dumb, but yeah, whatever, way it goes. All right, let mute i32 equals 0, or i32, we'll call this left i32, let mutable right, call this i32 equals 0, and let's build this up. So where are we? So this is 716. So got it. So basically this is going to be it's going to look like this. So it's going to be n node for n node in self dot iter dot enumerate. Yeah. So this is n is going to count up, and then I'm basically just going to take the node value. So I'm gonna add to left. I'm going to say left plus equals the node value. So that's going to be node borrow data times, and then it's going to be 10 to the power of n, just like that. Is that how you express power in Rust? I don't know. Cannot use plus equal on type i32. Left equals left plus. Expected type parameter found integer. What am I doing wrong here? i32 might need a bound for multiply. Okay. Do I need this? I don't know. I don't need that stuff because, well, maybe I do need that stuff. Never mind. Take it back. Take it all back. 32, 32, 32, 32. Whoops. Guess I need to do that. Did it. Alright, that's not how you Rust power function. How do I pow in Rust? You don't need the num crates, nor do you need blah 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 pow. Okay, let's try that. 10 pow n. Like that. Pow 10 pow n. All right, let's give it a try. Cargo, 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 cargo test. You can't call pow method on ambiguous numeric type. Okay. 10 i32. How's that? Cannot add dir to integer. Expected type found type. Can I do that one? Let's try that one. i32 Pow. Function. Oh yeah. Oh yeah. Okay. What am I not understanding here? Use the POW methods directly. I32. POW. Power. Help, convert the identifier to count. I see. Okay, so it thinks that this is a generic type here, which I'm not necessarily saying it is, but that's what it thinks. So let me just do this. Let's see what happens. T. All right, fix all of those. Expected type T. Mismatched types. Expected U32 found U size as U32. Cast that. Expected type parameter found I32. What? Expected type T. Oh my. No implementation for integer plus T as jitter output. All right, let me cast this. So let me say let value equal that as I32. Yeah? Something like that. Note, an as expression can only be used to convert from between primitive types. Consider using the from trait. Okay. So how do I do that generically? I thought this one was going to be easy. Seems like it's tricky. It's tricky with Rust, at least. I can't simply cast this. Rust is a number. Check. Primitive types. Rust num integer. I wonder if I can just use this T num integer. Is that a thing that I can do? Not found in is it a std num or just num? Use of no. Implementations. Rust type is Rust impl type is integer. Parameter types over numerics. What is the type? Integer. Rust impl where Rust impl where is integer. Generic over all integer types. Yeah, that's what I want. Traits, add assign, and sub. You can write, but I'll probably use nums 0 and 1 to complete this. There's a prim int which encapsulates a lot of generic traits. Num traits. That's another crate. Alright, I'm focusing on the wrong thing here. Let's see, ops, what? Multiply, add assign, add assign, yeah. See if that'll compile. No. No implementation for if I make that type T. Can't call a method pow on ambiguous error type. Okay, I32 like that. Expected type T. Can I say type T like that? You must specify a concrete type for this numeric value. Expected type T. Can I just cast this to a T like that? Expected type parameter found associated type. Expected type T. Found type output. Alright, I think trying to make this generic is just like too much effort right now. I don't want to do it. So I am quite simply going to make this a concrete implementation because I don't understand generics well enough in Rust to actually do that. So let me just try to do this in a non-generic way. All right, let me change these parameters to left and right, left, right, left, left dot iter. There should be left something like that. Okay, fix these. There we go. That compiles. Okay. Good. Making progress. Put this down at the bottom. So sum up the left. Okay. Sum up the right. Do the same here. Place left with right. Place all. Okay. So left sum, we have left sum, we have right sum. Now let us go and, so we're supposed to return the value as a list. So let's go down here and just update the tests. So this one is called test sum, what do we call it, backward or something? Or add backward. Let me change it from add to sum. Sum backward. I just move the code down here so it's closer to the test. Sum backward. Test sum backward. Okay. Let result equal sum backward left and right. Okay, and then let mutable iter equal results dot iter, and then assert equal I was trying to type a pointer the C plus or C way out of habit. So the results should be equal to 219. 219. These should be references. Next, borrow data. Borrow data. Borrow data. Is that it? Are we good? No, we're not good. Why doesn't it like that? Oh yeah, unwrap. I need to unwrap this. And I think that should compile. All right. So go back here, and then I need to actually sum these values, and then add them in the list. So let sum equal left sum plus right sum. That's pretty easy. Okay, and then I guess I have to do the reverse operation of this. let's see. This is a little easier to do when you have a binary-based, or sorry, this is easier to do when you have binary-based decimal system, because you can rotate digits and you can do binary operations on them, like mask a digit. In the case of decimal values, that's not quite as easy. However, lucky for us, there are some math things we can do. I think we can do this using the mod operator. Right? So, for example, if I have the number 11, right, 11 is composed of two numbers, 10 plus 1. Right, so to get 1 out of 11, I would just do 11 mod 10. Yeah? Let's try this in Python. 11 mod 10, that should give me 1. Now if I want to get that 10 out of here, I would do 11 divided by 10. Sorry, 10. I want you to do integer math. I think in Python you have to do double slash. There we go. 11 divided by 10. And then I would just multiply by 10 again. And then I get that 10. Right? So you can basically just like repeat this operation over and over to extract the different digits, depending on where you are. Okay. So, so I need to figure out how many digits, and the number of digits that I have is going to be equal to it's equal to the order of magnitude of my number, right? So like it's literally just, you know, if I have 100, I've got 3 digits. If I have 10, I've got 2 digits. If I've got 1, I've got 1 digits. If I've got 1,000, I've got 4 digits, so on. So the easiest way, well, one really easy way to get the number of digits is to just use string operations. In fact, this whole problem could easily be solved using string operations right now, like this particular part of the algorithm. And I'd like to do that. That would be nice. It'd be easy, just like print it to a string and then extract the digits, but I think I'd rather, I think right now I would rather do it the math way. So trying to figure out how many digits you have the math way is slightly more complicated. You have to, you basically have to do a calculation. You have to say like, so to figure out if I've got the number 1,000, I need to figure out I have 4 digits. So the way I would do that is I would say, okay, so 10 to the 0 is 1. Is 1,000 greater than 1? Answer is yes. We can do that. Like, it's easy to check that 1,000 is greater than 1. So we know we have more than 0, we'll call it 0 digits, right? Okay, then you do another check. You say, okay, 10 to the 1th, that is 10. Do we have do we have more than that? Yes, we have more. You basically repeat this process, whoops, until you get to 4, right? And you compare this number to that number and say, oh yeah, we have less than that. So here we go. That's the number of digits, right? So let's repeat that algorithm. Let's do it here. Let's go for, actually we'll just use a while loop. We'll say let mute digits equals 0. And we'll say while 10 i32 dot pow digits. So as long as this number is less than or equal to the sum, increment the digits plus equals 1, right? Does that compile? Yeah, cool. Okay, so this should give us our number of digits. Once we know the number of digits, we just have to go through each digit effectively and pull that field out or value out. Now, because the digits are stored, it's like little endian, right? So we're storing the little n first. We're going to start from that direction. And so we just say for n in, start at the number of digits down to 0. This is going to do what I want. Is that inclusive of 0? Let me think. How does Rust work? How do ranges work? Rust range inclusive. I know. Oh yeah. There's a syntax for an inclusive range. It's ... equal. So inclusive means that it will include this value in the range. Exclusive, which is like ... normal one, means it stops before it gets to that value. So this is fine. I don't need it to be inclusive. Okay, so extracting the first digit is basically going to be this number. It's going to be the sum. Let mute digit value equal. It's going to be the sum divided by the power of this digit, which is n. And that should be it. So then we append that to the list. Guess that doesn't need to be mutable, right? Oh, sort of. We have to mod that as well. It does need to be mutable. I forgot that. Well, I could do it on the same line, but I'll do two operations. Digit value equals this guy modded with 10. There we go. That'll give us what we want. Boom. Function is never used. I think that should be it. Let's use our function. Sum backwards. It is used. It's used right there. I guess it's because it's used in the test and that doesn't count. Unwrap on a none value. Oh dear, what did I do? Append. Doing something wrong here. I think my my algorithm must be wrong. Let's run with this and just see where it blew up. It blew up at 171 here. So result, sum backward. The list is empty, it must be. New list, append for n in digits. Can you have a reverse range in Rust? Rust reverse range. Is that a thing? Uint for loop looks like this. Oh, I see. Okay, I did it wrong. Like this. I need to use this reverse thing method, whatever. Cargo test on the range. It's still wrong. It's still blown up. Left 9, right 2. I think my reverse is not going in reverse. Wait a minute. Oh, yeah, of course, I'm doing this backwards. This should not be reversed because it's a little endian, yes. So I want to count up. There we go, boom. That is done. So the other one to implement is basically the exact same function, but forward. So sum forward. Let's do that. So this is all going to be mostly the same, except here, this value is going to be it's going to be the length. Oh, we don't know the length. We don't know the length because these are... It's a little tricky. In order to do it forward, it is a little slightly trickier than I thought originally. Because this is a linked list, you don't know the length necessarily of the list without actually going through it. It is easier to do the backward version, obviously. So this part we can do easily. Let me just reverse that. But these algorithms are not so easy. So I think one way to do this would be to just extract the values into a vector first, like this. So just say let left vec equal left dot iter dot map wait, how do can I convert, or can I return an iterator or a vector from a map? Rust iter map into iter map collect. Yeah, I think collect will do map value. I'm just say node dot borrow data collect yeah. Let's reverse it first. Can I do that? Map. Takes a collision, creates an iterator. Reverses an iterator. And then collect, transforms an iterator into a collection. I think I need to specify the type, vector, 2. Yeah, like that. Will that work? Will that do what I want? Left, back. Changes the value. Why am I still getting squiggly lines? The trait double-ended iterator is not implemented for Iterator 2. Ah, it's because, okay, that's fine. I can just do collect on that and then I can reverse it again, right? Like this, reverse, enumerate. Yeah? Yeah? Does it work? Boom! All right, we're cooking with gas. Right vec, right, value, vec, iter, reverse, node borrow, and it just changes the value. Boom, boom. I think that should be it. Okay. So I'm kind of cheating, but I don't really care. I think this is good. Yeah, let's add another test to test sum forward. Test sum forward. What is the example they give in the book? Let's copy that. They give the exact same example, but the values are reversed. That's good. Makes it easy. Move the 7 down there and the 6 up here. Move the 5 down there and the 2 up here. And then same with these guys. 2 down there, 9 up there, right? 912. Is that right? Yes, 912, 617, 295, 912. Boom. All right, test that, cargo test. Ooh, ooh, not so good. Not so hot. 9, 8. No. No, no, that's not right. 0 up to digits. Reverse. Okay. Not totally sure why that doesn't work, but must be something wrong in here. So let's just add some print here. Left sum equals that. Okay, right sum. Sum. I need to make sure I'm printing the output to test sum forward. Oh, I'm calling the wrong function. There we go. Oh, there we go. Passed. So there was actually nothing wrong with that code. I was just calling the wrong one. Save that. Boom. All right. We did it. We did it. Problem 5 is done. There's only three more problems in this one, and just for a little preview, the next 3 problems are palindrome, implement a function to check if the linked list is palindrome, intersection, given 2 singly linked lists to determine if the 2 lists intersect. And then loop detection, also known as the tortoise and the hare. It doesn't say that in the book, but I've been asked this question many times, and the right algorithm is known as the tortoise and the hare algorithm. Given a circular linked list, implement an algorithm that returns the node at the beginning of the loop. Yeah. Cool. So let me go ahead and commit this new problem. Git add source bin. Yeah. Let's add problem 5. Push that up to GitHub. And let's take a look at the Clippy issues that I have here. So let's run Clippy, see what it's printing out, and then go address these. Oh man, I got a bunch of them. Okay. Method is never used. All right, that's easy to fix. Let's partition something. Okay. Okay, that one should be fixed. Let me just check to see if oh, thank you. Yeah, Doge likes being a star on the TV. It's pretty nice. I get to watch her all day when I'm at work, which is entertaining for me, and other people enjoy watching her. All right, let's fix some more of these Clippy things. What else is busted here? There's so many. Oh, okay. Dead code partition. Are these all in chapter 5? Yeah, I think these are all in chapter 5. Okay, that makes it easier. Sum forward never used. Well, let's add that here to the test. Let's go sum forward. Let me just add 2 lists down here. Just to make the compiler make Clippy happy. Left, right. Sum backward. Clippy is going to be so happy. So happy. Let's fix this one in problem 2. Where this is the one I fixed earlier, the Kth problem one, where I can just use a yeah, instead of counting myself, I can just use enumerate on this. That's good. It's pretty awesome, Clippy. Really good at fixing my codes for me. Uh-oh. I broke it. If k as, sure, whatever, let's cast k to a U size. Or maybe just make k a U size. Why does it need to not be a U size? I think that's fine. No, failed. This one, these guys should be like that, like that. That should be references. Okay, beautiful. Test pass. What does Clippy think? What's Clippy thinking? Help, replace it with bloop equals. Alright, it's a good suggestion. Mod equal 10. It's a good one, I like it. Mod equal 10. Mod equal 10. Plus sum, plus equal. Plus equal. Plus equal. Plus equal. Plus equal. Oh, we're so close. Never used. Partition. Yeah, well, I'm just gonna get rid of it for this. I should get rid of whatever else I'm not using in here. Clean up problem 4 as well. Tidy that guy up. And cargo test. Clippy. Got a few. Need to remove. Oh, use that in here. Get rid of it. Don't care. Remove is not going to be used in here either. Get rid of it. Don't care. Get you out of there. Throw it away. Throw it away. Get it out. Boom. Cargo test. Boom. Apply. Clippy fixes. Push that up to the GitHub, and I think we should have a build here that's succeeding. All right. Let's see. Takes a little while. Travis is kind of slow. I was mentioning earlier how I've been slowly replacing Travis. Well, not replacing, but I've been adding GitLab's CI to some of my projects, open source stuff. That's what I worked on all of last weekend, and I like it. It's, you know, it's pretty good. It has its issues, but it's pretty good. Let's follow the log on this build, and I think everything should be passing. By the way, if you want to check out the actual code for this project, if you're just tuning in, you can find it all on GitHub under my name. My name, no vowels. Cracking the coding interview Rust. Let's see. Shall we do one more? I've only done two problems. I guess I haven't done that many. All right, Palindrome. Let's do this. Let's do Palindrome. So I think there was a Palindrome problem already in chapter 1. Let's do this one. Let's take a look at it. Palindrome. So here's the problem. And if we can get the camera working here, maybe not. Every time I try to do this, I don't know why it has problems focusing on the book. It works, it just takes a while. There we go. All right, palindrome. Implement a function to check if a linked list is a palindrome. Right? Cool. So what is a palindrome? It is something that is the same forward as it is backwards, right? And earlier, if you remember, in the last problem, I discovered that I cannot merely use the reverse trick in from the iterator because it's not a doubly ended iterator. It can't go both directions. So I've got a few ideas for how to do this one. One idea would be I could turn my singly linked list into a doubly linked list and keep track of the head and the tail. There we go. Looks like the build passed. Yep. Keep track of the head and the tail. So that's one option. What are the downsides of that? The downside of that, I think mainly is just that it would take me probably a really long time to properly implement a doubly linked list here. Maybe not, maybe it's not that hard. Let me think about it. It's not, I guess it won't be that hard. I don't know if I want to do it right now though. Another option, so let me just close these and create a new file here. Copy this, copy, paste, problem 6. Test is palindrome. Okay. Get rid of this test. Change this to list. Let's go cargo test. Make sure that's building and everything. All right, cool. Whoops. All right, so how to do this? I guess like one way to do this that would be relatively easy would be to use a vector and just iterate over the list and push the push items into the vector, like literally just iterate over the list, push everything into the vector, and then use a vector instead of the linked list. That's probably the easiest way to do this, but I think that's cheating. That is essentially avoiding using a linked list. Probably the only right way to do this is to implement a doubly linked list. So how about I just do it? Let's just implement a doubly linked list like this. So there isn't really that much that's different about the doubly linked list, except that we've got a few more pointers, right? Instead of just having a next pointer, there's a previous pointer, obviously. Another thing is that if you have a doubly linked list, you probably also have a pointer to the tail of the list instead of just the head. So, yeah, and interestingly, yeah, so I actually implemented tail as a function in the last implementation of this, but if I keep track of the tail as part of the list, then I can simply use the tail from the list, which makes things a lot easier actually. So let's do that. Okay, so iterator. So to get an iterator, right? First iterator, or first iter item here is going to be next previous self. Actually, this is just gonna be none. Sorry. Let me look at what a Rust double-ended iterator looks like. Nth back rfold rfind. Something that implements double-ended iterator has one extra capability over something that implements iterator: the ability to also take items from the back as well as from the front. It is worth to note that both back and forth work on the same range and do not cross. Iteration is over when they meet in the middle. Huh. Okay. Interesting. Some again. So in similar fashion to iterator protocol, once a double-ended iterator returns none from a next back, calling it again may or may not ever return. Some again. Next and next back are interchangeable for this person. All right, cool. Next, next back, next back, next back. Removes and returns an element from the okay. So I think that sounds pretty straightforward. So to make a doubly ended iterator, I think I need to implement this next back. Yeah, next back. And then this basically becomes, this is going to be previous, 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 return some, blah, blah, blah. Yep, that's easy. Basically just change all of those and then change this to double-ended iterator. Double-ended iterator. Okay. Iter t previous next. Okay. And then so I have to do one more thing here, which is when I append, I need to do something slightly different. So in the old code, in order to get the tail, I literally needed to had to implement this tail method, which actually iterates over like the entire thing. However, I don't need to do that anymore. I can merely say return self.tail as ref cloned. That's it. And then all I need to do is keep the tail up to date. So this guy does not need to exist, I believe. And I can say self head none, tail none. So that's the initial state. And then every time I append, I always update the tail. the tail will just become a pointer to this new guy here. So yeah, so tail will become self.tail will be replaced with tail, borrow mutable, cloned, or I'll just do tail borrow cloned like that. And in that case, so this case here is where there is a tail already, and this case is where there is no tail. So this is an empty list, and in the case where there is no tail, the tail and the head are the same. So tail is going to be equal to self.head, borrow clone, like that. Cargo test. ART is not an iterator. Oh dear. Why is it not an iterator? Double. Let's clean that up. Cargo format. Why is it not an iterator? Double-ended iterator. Oops, cargo test. Clearly did it really wrong. Type item is not a member of trait. Double-ended iterator. Okay. What did I do? What did I do wrong? Do I have to implement iterator and implement double-ended iterator? What's going on with my web browser? Rust implement double-ended iterator. Iterator for, okay, I think these need to be separate traits. That's why this is messed up. Yeah, it must be, that must be it. Okay, let's move this here. Do that, change this back to what it was. How are we doing? Cloned for blah blah blah. Line 39. Self.tail equals. Oh, there should be some for one. Tail. Should be borrow clone tail. This is probably already borrowed, no? No. Borrow. Do I need to borrow mutable? No. No. hold on a minute. Sref cloned. So some tail is tail. So if this returns some, then I have a tail. And I just want to borrow that tail, but this, I think it just needs to be dereferenced, right? No method cloned. Am I dereferencing it too much? No. Next. It's back. That's right. So I'm pretty sure this needs to be borrowed here, right? Is it clone? No. This is an associated function, not a method, right? Yeah, it should be cloned with a D. Cloned with the D. No method name cloned found for ref. Rust, ref cell, rust. Cell. Help me clone. So, so I already have a ref, but I want to clone this ref. Oh, I see. It's because I do not have a mutable ref, right? So if I have ref mutable, can I clone that? Maybe I'm not even... No, it should be borrow cloned. Tail as ref cloned. Cloned will return option by cloning contents. Yeah. So this is a node ref. Node ref is RC. Yeah, RC ref cell. Let me also just get rid of this tail method. Seems superfluous. So tail, self tail. Tail's an option, right? So I have a node ref. Node ref is an RC ref cell. So, okay. As ref, I think I may need to unwrap it once more, right? No method. How do I clone my cloned? Borrow cloned. Can I just clone that guy directly? I'm so confused. RC. Rust RC clone. Implement clone for RSL. Oh yeah, I'm also not setting previous here. So in the case of this, there's no previous. In the case of this, the previous is the last tail. Hold on. Let me try to figure this out. Self tail. What am I messing up? I'm messing up something. Borrow previous clone. Expected enum. Oh, there we go. Okay. In this case, previous is also none because there's no previous. Tail. Should just be a head clone. There we go. I think. What did I just do? Expected. Self head clone. Oh, there should be borrow. As ref. Self head as ref cloned. That's right, isn't it? Expected struct. Found option. What? Some line 51 right here. Yeah. Oh, because cloned with a D returns an option, right? It should be as ref. Yeah, as ref cloned. There we go. Okay. That's fun. All right, so in theory, I should have a doubly ended iterator that works. Let me just write a test that test iterator forward, back, reverse. Let's just make sure. Let me just make a vec here. So I'll just say call this vec list vec, and we'll just say 0, 1, 2, 3, 4. Okay. And then let vec list. Let's call it. Let's call this vec forward reverse equals vec forward dot map, or can I just do dot collect? Can I just do reverse? Oh, there we go. Okay. And then if I make two lists here, just like this, list forward, and then list reverse. And I go for value in vec forward, list forward dot append value. Okay. Cargo test, mutable, clone. There we go. Okay, I had to make a copy of this vector because this guy is mutable, or is like a in-place operation, I guess. Okay, and then for value in vec reverse, list reverse dot append value. So now I should have two lists, two vectors for reverse, so on. So let's just reverse both of them for value in list forward. Well, let's assert that like going forward works. So we'll do I value dot iter enumerate. Okay. Assert equal vec forward I, and then I borrow data. Do that with the other one. Reverse. Oh yeah, I need to unwrap that. Unwrap. This is an option. Unwrap, borrow. Index into value expected back by 32. One moment. I'm gonna pause for a second. I'm back. Swallowing. Sorry. Took a little break. Had a little snack. Got some fresh tea. Hot tea. I like to drink hot tea just like Picard. Earl Grey tea. Hot. All right. I think that's funny, but I might be very alone in my amusement of that type. All right, I'm just trying to write a test to make sure that my doubly linked list actually works. So that's that. And it does not work because I'm using this reverse thing wrong. So let's do this. There we go. A semicolon here. Writing tests is always good if you can, if it makes sense. But writing tests is also a little tricky. It takes a lot of time. It's not always worthwhile to write tests, especially if what you're testing takes so much work to figure out how to test that it's not really worth the value of the tests. Like, for example, if you're building something that, say, talks to an API, and you would have to like mock out the entire API, that might be a case where it's not really that useful sometimes. I don't know, it depends on every situation and circumstance. When it comes to algorithms, things like that, it's like usually pretty valuable to can't borrow is mutable. What? I see. It's because I'm trying to modify this guy. Alright, there we go. So, something's failing, which I guess is either good or bad, depending on how you look at it. It's good that something is failing, that means there's something wrong. I don't know if the error is in my tests or in my algorithm, but we will find out. Whoops. Okay. What is failing? Line 121. Oops. Line 121. Insert equal. Oh, that shouldn't be failing. Left equals right. I don't think this is working the way I expect it to work. Okay, let me just do this the old-fashioned way and just like copy and paste. Or not copy and paste, but like write it out. 4, 3, 2, 1, 0. All right. Cargo test. Okay, that is wrong. List forward. Why is it failing? Why is it failing there? It's failing at line 120 here. Left, right. How do you borrow data? I must have an error in my code. Oh, you know what? I think my tail is not, I'm not updating tail properly. Okay, so let's look at this again. So okay, so when I do an append, right, if there is a tail exists, I'm appending to the tail. So oh yeah, this is wrong. So if the tail exists, my new tail is actually going to be this. This guy here. So my new tail becomes my new value here that I just created. So the way I should do this is like this. So I'd say let new node equal that. Okay. That is my new node. The previous is going to be the previous tail, so that's right. Yeah, that makes sense. Okay, so, and then the previous tail's next is going to become this new node. Okay, clone that. And then my new tail is also this new node. These are options. I think that is it. Boom, test pass. It's so satisfying when that happens. Okay, I didn't actually test the reverse iterator yet. Let me make sure that that's right. So to test that, I'm just gonna copy these guys, do the exact same thing, but do iter, reverse, enumerate, and then this should be the reverse. And then do the same thing on the other one, but it should be forward. Like that. Cargo test. Boom. Love it. Love it. It's so satisfying. So satisfying when your computer codes actually work. All right. So I just spent a long time writing all that code just so that I can solve this palindrome problem, which is not a hard problem. If this were a real life interview, of course, I would have never gotten to the end and probably would have failed the interview. But probably a good example for why you shouldn't do your interviews in Rust unless you're some kind of super genius. Or I guess if the person interviewing you knows Rust really well and they understand that it might take longer to do things the first time because you have to basically boil the ocean every single time, then yeah, you might have a good time. I don't know. We'll see. If anyone has tried to do coding interviews in Rust and had a good experience, let me know. I'd be interested in hearing all about that. Okay. Palindrome. So there are a few really easy ways to solve this problem, by the way. One really easy way is using a stack. You just push into the stack and then pop off and have a good time. Another easy way is using iterators. So let's make some lists. Let's make a list here. List.append 1, 1, 2, 3, 1, 2, 3, 2, 1, let's say 2, 1. Okay. And then we'll say assert equal is palindrome list true. Oh, we can make this a trait. Say list is palindrome 2 true. Let's make both of these. List 1, let's call this list 1. And then let's make one more. It'll be essentially the exact same thing, but we'll add one more value at the end here that makes it not a palindrome. Okay, call this list 2, 2, 2, 2, 2, 2. Okay, list 1, and list 2, and this should be false. All right, so let me restart the RLS, try and fix it, fix my code formatting. There we go. Okay. Let us go ahead and implement that. Function is palindrome. Takes in self, turns a boolean. Let's just say it's false for right now. Okay, so let's get an iterator of this guy. So we'll just say let iter equal self.iter. Okay, got an iter. And let's look at the documentation again for this guy. So what I want is to iterate forever using these guys, and so from the documentation here, the double iterator, it says that returns none from next back, calling it again. It also says that it is important to note that both back and forth work in the same range and do not cross. Iteration is over when they meet in the middle, right? So that's interesting. That means that this double-ended iterator provides a convenient feature for me that makes this code fairly easy to write and concise. So if I basically what I need to do is I need to have two options. So I'll say call this left equal none. This is, well, okay, we can use the first items here. Left equals none, and then right equals, or this, sorry, hello Dumitru, is that right? Dumitru? I apologize if I'm doing a poor job. So I'll basically say while left dot is sum and right is sum is sum. Okay, and it's pretty simple. Actually, let's call these front and back. Those are better names. So while front is sum and back is sum, these are basically pointers to the front and the back of my linked list, doubly linked list. This should be a mutable iterator. Yeah, mutable iterator. There we go. All right, so if the front is not equal to the back, so if these are different, return false. Okay. Easy peasy. My option, oh, these are options. I need to unwrap that first. Unwrap. I already checked. I'm checking that they are some. What am I coding? I am implementing, I'm going through this book. It's called Cracking the Coding Interview, and I am implementing the problems using Rust-Lang. So if you want to follow along and check out the code, it's on GitHub. And just go to my name / Cracking the Coding Interview Rust, separated by dashes, and it's up there on GitHub. Okay. Borrow of moved value. No, don't do that. Do I need an asref in here? Uh-oh. Okay, what? This is returning an option. That should be fine. Move occurs because why does that force a move? I'm actually not sure. I understand right now. Value borrowed here after move. Value moved here in previous iteration of loop. Oh, okay, duh. I need to update these in each iteration of the loop. Okay, back equals iter dot next back. All right, and these are mutable like that. There we go. Test fails, that's fine. I'm not done. So here I would basically say if front is some, or if either of these are some, are valid values, that means that it's not a palindrome. That means that I haven't exhausted all of the values, essentially. I am coding this in Rust-Lang. Return false. I need an explicit return statement in there. All right. So I think the code is done, but my tests are failing, which means something is wrong. What have I done wrong? Test is palindrome. All right. So 159. 1, 2, 3, 2, 1. Yep, this one's definitely a palindrome. That should evaluate to true. This one's definitely not a palindrome. That should be false. Let's start doing some debugging. See what's going wrong here. Okay. Print line front equals this, back equals this, and then I'm just gonna copy these. That might cause another move, maybe. Oh man. It's not letting me do that. T cannot be formatted because it's not oh. Let's see if it works. Oh, okay, that's fine. As ref. Whoops. As. No method name borrow for as ref unwrap. There we go. Okay. I always forget what the, there we go, dash dash no capture. I want it to print out my print statements. It's blown up. It's blown up and I don't see my statements. Where are they? Line 165 is palindrome. Well, front, okay, so maybe front and back, maybe these are not. Is there something wrong with my double-ended iterator here? Is my tail, yeah, okay. So, my tail should be in, or my double-ended iterator tail should be initialized to the previous value should be initialized to the tail. Boom, there we go. Front, back, front, back, front, back, front, back. Sweet. So it looks like it's kind of working, but also it's not working. Why is that? It's blowing up at line. Thank you for the compliment of my code. It's blowing up at line 174. So this one is failing. So I think what's happening is I've got some error in my in my code here, and it's going past the end or something. Oh no. So this should be left. So this guy is returning true when it should be returning false. Let me just add this to get rid of compiler warnings or linter stuff. So I'm not correctly handling the case where it is. So I think my implementation here must be wrong. My implementation of the double-ended iterator. I think that I need to actually check if, so like when I return the next here in my iterator, I need to check that these are not actually the same. So I can do that by saying if self.next equals self.previous, return none. I believe. Right? If these point to the same thing as ref, do I need to unwrap this? Probably. I maybe don't need that borrow. Is that gonna compile? No, still not happy. Okay, how do I compare two refs? Rust cell. Compare. Equal. No, Rust. RC. Oh yeah. Pointer equal. That's a method on this guy. Like that, I think. How are we doing? Is that gonna compile? Yes, sweet. Okay, and then I need to do the same thing, but for the reverse iterator, which is, and whatever, that's fine. All right, still failing. So that is a bummer. Why is that failing? Next. Mess something up here. Front and back, panicked with left. Panicked. Okay, if these are equal, these should definitely not be equal. Not in this context. Why are those guys equal? Why are they equal? But they should not be. Oh, I'm looking at the wrong pointer. This should be, I should be comparing this to the current one. Okay. Yeah. Blah. I should use this, yes, and then here right? No, still not right. Okay, so let me just look at this code again, try to figure out what's going on. So I'm comparing the pointers, right? I'm comparing the current, which is the next. And I'm comparing that to the other the other one, the previous pointer. And so they are not supposed to overlap, but I'm letting them overlap, and that is where the violation occurs. Unwrap equals. So I think those are right, but it's still blowing up. Front, back. It seems to blow up after just like one pass through here, which means like these guys are not working correctly. I clearly have some kind of bug in here. So previous is the tail. Yeah, that's right. Next is the head. That's how it's initialized. And yeah, each time you call these, previous, next, 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 previous. That all looks good. But, so the case is if if the next one, oh, no. So, yeah, this is wrong. This is going too far. This should just be this. Yeah. Okay. Same here. This should just be the current one. It's like looking too far ahead. Sweet. Sort of good. Test palindrome. So I think okay, so this is the case where both of these should be none, but I think it doesn't happen because one gets to be some before the other. Right, because they're going to meet in the middle and then stop. So this needs to be slightly different. So this should be if I break out of this loop, I think yeah, 1, 2, 1, 2. So this is not going to be true because this is the case where let me just go back here. So this is going to go 1, 1, 2, 1. That should return false. Oh, there we go. There we go. Boom. All right, that works. We got it. I had an error in my test as well, in addition to the other errors in the iterator. Let me have one more test case here. maybe a couple more test cases. Want to test an even number of values, so like 1, 2, 2, 1. Three, 3, 3, 3, 3, 3. So that's a palindrome. Sweet. And then one more case with an even number that is not a palindrome. Yeah, 1, 1, 2, 2, not a palindrome. Close. Test 4, or list 4, 4, 4, 4. It should be false. Nope. Yep. Passes. Sweet. All right. That is that. We did it. We're done, team. We're done, fam. My fam. All right. Let's run Clippy. See what Clippy has to say. Holy cow, I made it through some code without any complaints from Clippy. Let's add that problem. Add chapter 2, problem 6. Git commit. Git add source bin. Git commit. Problem 6. Problem 6. Push that up to GitHub. There it is. 12 seconds ago. Boom. Let's take a look at the Travis build. Make sure that succeeds. I believe it will. Wow. Wow, what a thrill. It has been really fun. I think I've been streaming for how long? I'm gonna check my phone here. A little portal. Yeah, 3 hours into it. Sweet. Anyway, I'm gonna let this build finish, and I'm probably gonna call it a day at this point. Thanks for tuning in. If you have, maybe we should go find someone to raid. If anyone has any suggestions, let me know. Let's see. Looks like none of my followed people are doing anything, I guess. Maybe I need to find some more channels to follow on Twitch. All right. Anyway, the build's going. Thanks for watching. I hope you enjoy it. Hope you get some value out of this. Check out the GitHub project. Check out the project on GitHub. If you want to see the code, it's right here on under my GitHub profile. Just go to my name, Brenden Matthews, no vowels, / cracking the coding interview Rust with dashes separating the words. This is the book, by the way, that I'm going through. You can probably save yourself the effort. Don't bother buying it. I mean, do buy it. If you think this work is valuable, like support Gail here, the author, do buy it. But if you're like me and you're just doing this because it's an interesting way to learn a new language like Rust, then, I mean, I don't know, do what you want, I guess. I don't really care. But the solutions are all over GitHub, so you don't actually have to buy the book to see the problems. If you are, for example, new to programming, like if you just finished school or something and you want to get a job at one of the FANG companies or whatever, then I do recommend buying this book because it's a good way to learn quickly what you need to do to pass tech interviews if that's what you want to do. Although I should mention that just as a matter of my own philosophy or whatever, I'm generally opposed to these cracking the coding style interviews. I think they're kind of stupid, and they don't really provide the kind of signal that you actually need to find anyone talented if you're trying to hire people. So that's that. Anyway, just my opinion, my 2 cents. Code built, everything's passing, tests are good. Thanks for watching. Take care. Bye-bye.